Hello everybody, we're going to be working through this money in the utility function model, and here it is. So the first line I have here, I guess this one, as you can see, this is your constraint, and because it's a money in the utility model and not a cash in advance model, we only have this constraint here, and then we've sort of defined the utility of CT and MT as such. I can't take credit for this exact, or I guess I couldn't take credit any which way, but I definitely can't take credit for this model here or exactly how it's being described. This was just on one of my assignments and I'm solving it again, so this would be my prof. And so, but we're gonna go through it. Our first objective here, so what we're going to be doing today is we're just going to be finding the Eulers. We're just going to be finding the Eulers equation. So your first thing to do is set up your Lagrange. I misspelt it. Lagrangian. Okay. So what is that going to look like? So first, come on, you got to get pretty with it. You do your summation because gotta get your time periods in there. This is the I think this is important to mention. Obviously, we are expressing our agent's budget constraint in real terms in period T. Okay, so that's what this is. Real terms. It's in per capita and all that fun stuff. So let's get started here. And we got to get all this right. So first you're going to put your utility, and I'm not going to put, I'm not going to sub it in. I'm not going to sub in what the utility is just yet. It's not super important and it can get confusing. So I'm going to leave it as such. It's not important. And obviously you've got your lambda at time t, bracket, function of, and this is similar to just having your y here. So, this is your, I think this would be y at time t. Okay. Don't quote me there because maybe it's y at time t less 1. Actually, that would make no sense, I think. So maybe it is just time t. But it's not super important. It's a function of k at time t less 1. And so it doesn't, I wrote it up here too, so I'd be wrong twice, but I guess, I don't know. We're going through the math, not really the theory today. I've been talking a lot about theory as of late, and I feel like I'm kind of sick of it. Well, I'm never sick of it. I love the theory. I'm just not very good at it. I'm also not very good at the math, so maybe I don't know what I'm talking about. But anyway, here we are. Now, this might seem like quite the process. You're writing all this stuff down, but it's important to do it because, on a final or what have you, or on an assignment, or you might want to just have it cooking from memory. Tau's a fun one because tau is equal to oh my gosh, the movement of money. Give me a moment here. I said I wouldn't talk theory, and I'm getting right into the beeswax. If I could find it, because I don't want to say something and then be wrong. Although I guess that would be like me, wouldn't it? Just give me 1 second here. Well, it did say on the assignment. What's tau equal to, huh? Oh, it literally says right here. Okay, it's tau mt less mt less 1 all over the PT, the price level. Okay. Bada bing, bada boom. So that's cool, I guess. You can think that's cool. So we've got this. We're not done yet because you got to move all this other stuff over. Less CT, plus mt, sorry about that mt, but I'm not gonna fix it, kt plus bt. And you just close it up. Et voila. So this is your Lagrange, and I know it looks a little hefty, looks a little heavy duty, right? But you just don't stress about it. You've got all your things to maximize up here, so you're like, okay, well, let's do it. Let's get right into the meat and potatoes. And that's exactly what we're gonna do. So you do your silly little Lagrange of CT. And I don't even have to look, but I guess you could. All right, so this is a function of CT, you know that's gonna be there, and that's less CT, and that's associated with that. So you're like, okay, well, this is like, you know, at this point you're a pro. And I'm gonna put CT down here, or I guess maybe C? Sure, because it's being, it's a derivative with respect to CT, not MT, and you kind of want to make that clear. And so this is gonna give, okay, and maybe I should have just done this in one step. Not wasted your time here, but you know, it's important stuff. Okay, so you have this, and this we can kind of think about now. We're like, okay, well, that's kind of interesting. This implies, you know, we're working with infinite time periods, so we can kind of have fun. And this is still BC. Right? Right. Ooh. And that's kind of helpful. That's going to be helpful. Yeah, whatever, man. I don't know. Putting CT plus 1 down there might be a silly decision, but I'm full of those. And so that's kind of beautiful. No, there wouldn't be any point of really doing that. Wouldn't really be any point in doing that. It's supposed to just emphasize if it's C or M that it's got the business towards. Okay, next. I don't want to take too long on the partials here, but I think they're important, so get good at them. Again, it's the same thing, and you're looking at this and you're thinking to yourself, how do I get, so this is MT, this is T less 1, so what's the dealio here? Again, because we're working with a whole lot of time periods here, you can't, Big Sauce just said hi. That's my sister. I'm going to Canadian Tire. All right, that's great. I wish I was on, please come with me. I'm not going to, and I'm also going to turn off, I'm going to put myself on Do Not Disturb here. So I don't want to go to Canadian Tire at this very moment. That's my sister whom I care about deeply, but also would be great if she just went to Canadian Tire by herself. Okay. BT, UM, CT, MT. Okay. See, you got the M here. That's cool. Oh, I was in the middle of a thought. Yeah. T less 1. So this is at lambda t, so it's lambda t plus 1. You betcha this is going to t. So that you need to be thinking about that, and you need to take that derivative correctly. So now you got plus, well, actually, no, I guess we should do less lambda t, because you're going to have the same thing coming from here, like the CT, and then you're going to have plus lambda t plus 1 times 1 over 1 plus pi t plus 1. And that's because this whole thing, that t goes to t plus 1, and obviously this goes to t, and then that falls to 1, and Bob's your uncle. This is equal to 0, and then this gives okay, so you could, I'm gonna do this now because I feel like it's important. Excuse me, I did a little burp there. So you got this stuff right here, okay? I should not have put t plus 1. That is my bad. That is my bad, gang. So CT. Oh, you know what? I gotta surrender that. Okay, so this, where is it? What am I looking at? Okay, so this is easy because we're just gonna put that prime there for the movement with respect to CT, and then double prime, or sorry, not double prime, CT plus 1 with respect to the next time period here, okay? And then this derivative is equal to, and you can do this derivative, it's not that hard. But I'm just going to speed run it. I'm just going to give you the answer here. It is equal to B less D bracket 1 less ln mt. At least I believe that's what it is. I kind of just... I am wrong, if you wouldn't believe it. I think that's more correct. Or that is correct, more or less. Yes, I'm going to say yes. Yeah, so that's it. You can just trust me or you can do it yourself. I don't really care. But it kind of just makes things more simple. And then this gives you BT bracket B. I got to see what I did there. It's D 1 plus ln mt. Bob's your uncle. And that bracket is equal to T less. And by the way, this is important, and I haven't been doing it just yet, but I'm going to do it now. Plus 1. So I'm going to use a different color here. Maybe red, because we're getting freaky. These are important little things that we've created here. I'm going to call this bad boy 2. And I'm calling these bad boys 1. Okay? And you'll kind of see why we're making this happen a little bit later. Maybe not right now, but definitely a little bit later. We're going to get right into the business of it all. But first, we got more partial derivatives to do, and you know what's coming. You're doing KT, guys. And I'm not even going to look up. I'm just going to do it because guess what? It's just life. Life comes at you fast. Sorry, just thinking there. And then obviously, or I guess not obviously, I don't even think I defined it, but you gotta trust me on this one. I mean, if you've done macro, you've seen this like 100 times, so you know what? It is what it is. This is pretty common to see. Sometimes you'll see like an A out front or something like that. Don't even worry about that. This is good. And then you have is equal to, and real ones are gonna see this next step coming from a mile away. Okay. RT, oh, that's a terrible R. RT is equal to, okay, and real ones just know this. Real ones just understand that this is just the case, okay? So therefore, and I said it, so I have to draw it. That's just the way that life works around here. Therefore, you've got this. Boom, 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 boom. And that looks pretty nice. And we're going to call that 3 because that's 3 all day. 3 all day. And you know what? I just thought about this. I got to expand my paper because my paper is getting a little full. I wish I knew how to do this. Crop and resize. Settings. It's 11 by 8. What if I said 11 by 20? Done. Oh, now we're talking. All right. So I just had a sip of my agua. We're getting right back into the action here. By the way, a little bit of theory for y'all. RT is the real interest rate. Look at that writing. Wow. Wow. He knows how to write words like there's no tomorrow. Okay, now last but not least, kind of least if I'm being completely frank with you, and we'll get into that later. We'll be roasting the heck out of BT all day, but it is helpful. You do need to know it. You need to know it, okay? And you know what? It's a similar thing to MT. It's a similar thing to MT, but it's not, but it is, but it's not, but it is. You know how it goes in economics, man. I don't feel like I need to bother you with it. And I almost want to do the Fisher relationship first, but I promised you the Eulers, man. I said so, and I'm like, I've lied before, and it's bit me in the butt, so let's not lie. We're going to do the Eulers, which, is going to be pretty easy. Or we could just do the Fishers, because it's, like, super, like, right here. And, like, I bet you're looking at it right now and just saying, why doesn't he just not do it? You know what I mean? Fine, I'll do it, man. Okay, I've been convinced. But then I have to do the Eulers. I just burped, y'all. Cancel me. Okay, so I bet you can see quite clearly 3 and 4 are just looking at us a little bit different. Okay, so we're gonna just put them equal to each other. And like, they're just looking at us. They're just begging to be equal to each other. So I mean, it would be unlike me to not oblige. And obviously, just like that, man, you don't even have to worry about it. And I'll show you a fun little trick here, because I'm just full of those. And you just have to excuse my writing. I'm sick of writing like a normal human being. So if a number, let's call it x, is close to 0, like small, you can do this little trick, okay? Take the natural log. Yeah, this is right. Thought I had messed up for a second. You take the natural logs. Yeah, this is right so far. This is T. Why am I... Gosh, man. Don't be forgetting your subscripts, dude, or else you're screwed. So bada boom, bada bing. And what happens is, so you have some sort of x that's close to n. You have 1 plus x, and x is close to 0, x close to 0, and then this is just, I guess you got to do like the squiggly. Sorry. This is like approximately equal to just x. So yeah, that's a little bit of a fun one for you. So this gives, again, approximately, it's not exact, RT equal to IT less IT plus 1. Okay? And it's sort of like a Bob's your uncle moment, So that should be correct. That should be right. Okay. So this would be the Fisher, or more exactly what I guess maybe you'd want to see, but like might not be that serious, is my teacher points at this relationship and calls it the Fisher. And so I think this would be more correct. Would get you full points on your quizzes. But this is the Fisher relationship. And I won't write down relationship, but that's what it is. And I showed you a fun little trick to get to this, which is fun. Okay. So, what's our next step here? I guess we do the Euler like I had originally promised. So, we have this up here. So, this is pretty cool. And sort of what we're going to do here is we're going to say, we're gonna put this on top of this, okay? And I'll try to show you how that's gonna look like. Okay, so first thing first, beta is gonna be doing some crazy shit here. Excuse my French. It's gonna land on top. We're also gonna use this notation, and so I won't go through the steps, but you're gonna end up with something that looks like this. Just like that, okay? I'm gonna check again, see if I'm on the right track. Yes, I'm on the right track. So this is, again, this is equal to that. And we know this right here. So you just have to believe me that we're gonna have this. Look down here. By the way, I'm just looking up here. This is equal to 1 plus RT. And we know that 1 plus RT, where is it? Where is it? I'm freaking out. This is that, okay? And so we flip that over. We flip that over. You'll see what I mean in just a moment. This up here, T plus 1, plus 1, plus that, over 1. Because you're flipping it the other way, man. So, therefore, you're looking at these two. And I'm silent because I'm building the suspense. And then you know what's happening next because you're doing it in Euler's. You know it's going to come. There we are. Oh! That's not what I meant to do. Boom! Bob's your uncle. That's your Euler's right there. That's a beautiful Euler's if I've ever seen it. Now, obviously, this is also equal to... I kind of like to have it in this form because it just like, you see more of the variables and then you can, learn. But obviously this is like the same thing. Oh, technically this is true. Right, yeah. I'm silly. I got a little bit ahead of myself there. We had a bunch of floating variables equal to 1. So this is the Euler equation. And that's all I'm going to show you today. So you got the Fisher, you have the Euler. Don't forget your brackets, everybody. That's important. You can't forget your brackets. And that's essentially it for today. We're going to work through more of this. We're going to have like we're going to find the marginal rate of substitution between M and C. We're going to find the steady states. We're going to be doing all that fun stuff. That's kind of it for now. Don't be scared by all the variables here because it's not that crazy once you really get into it. All the derivatives are not too bad, but it's still important, I think, to kind of show and to run down. So I hope you enjoyed the video, and I'll catch you next time.